Well, dear student, here motion of ball in the neck of bottle filled with air or any gas or maybe other topic in gas chamber. Let a ball of mass m is inside, it is in the neck of bottle whose area of cross section is capital A, and the ball is fitted in such a way air is not allowed to go out. Here, if the ball is gently pushed downwards, and released, it will oscillate to and fro about its equilibrium position. Let at an instant the displacement be x. Let at an instant displacement of ball from equilibrium position equal to x. तो decrease in volume of air A into x from definition of bulk modulus. Bulk modulus B equal to minus delta P upon delta V into V. V the volume of air, original volume, or minus sign indicate here degree in volume increase pressure, or delta P equal to minus V into delta V upon V. Increase in pressure If area is this, then F into F upon A, pressure force upon area, minus B upon V into A into delta X, or F is equal to minus B A square upon B into X. If M is the mass of ball, so this force will be restoring force, minus sign indicate it pushes up. So if I find the acceleration, then F equal to M alpha, where M is the mass of ball. So M alpha minus B A square upon V into X, or alpha equal to minus B A square upon M into B into X. So alpha proportional to X and omega square equal to B A square upon MV. Omega is equal to A under root B upon MV. So time period of oscillation T equal to 2 pi upon omega. So it is MV upon B or A outside. So this is time period of ball oscillating here. If compression and rarefaction are produced isothermally, you know, when we compress the gas, work is done. That work done, you can only heat the temperature, but if anyhow temperature of air does not change, then this actually the bulk modulus of air or gas is equal to pressure P of the gas. So we can write it as T equal to 2 pi upon A under root MV upon P. You may be given the pressure original was given by this. So in place of B we can use B. Now if the ball oscillates adiabatically, if ball oscillates and produces adiabatic change, then T time period 2 pi upon A into M into B upon gamma P. Gamma is equal to Cp upon Cv. Now you have learnt lot of physics for class 11. So please try to recall the things which I have taught. Now I take another motion. Here motion of disc or sphere suspended from a rigid support by a string. Here is the disc. Okay, this is the disc here. This, and it is placed centrally here. It is a disc. Let the moment of inertia of disc about acceleration be I. What is I? Moment of inertia. Now it is the equilibrium suppose here. Now if we twist the here is this we little displace it away from this position, then it the string will be twisted and due to twist, this wire or string will produce restoring torque. हम इसको खींचते हैं तो twisted wire will produce restoring torque. Let capital C be the restoring torque. Restoring torque produced. Restoring torque, per unit angle. Per unit angle of twist. So if theta be the angular displacement in the position of disk, then restoring torque produced by string or wire is given by tau equal to minus C theta. But C the twist produced per unit angle of twist. So theta is na. If capital I be the moment of inertia of disk about the axis rotation, about the axis of rotation, and alpha be the acceleration, then tau equal to I alpha. Tau equal to I alpha. You have torque. You have learned in class, na? Motion of rotation. So, combine two, we get I alpha equal to minus C theta, or alpha equal to C upon I into theta. Angular acceleration, position and displacement. So, motion is simple harmonic by C upon I constant. So alpha proportional to minus theta and motion simple harmonic. We get here omega, actually motion of SHM, alpha equal to minus omega square y. So here in place of linear acceleration there is angular, in place of linear displacement, angular displacement. So omega square equal to C upon I. Omega to under root C upon I. Remember, C is the restoring torque per angular twist. I is the moment of inertia. So time period T equal to 2 pi upon omega, or T equal to 2 pi under root I upon C. This question it will ask in competitive exam in other way also. And you must remember, actually you will learn in higher, if you go to higher physics, you will get some problem of oscillation, vibration, etc. So this was the motion of disk suspended through inextensive string. Now motion of a solid cylinder floating in liquid. Is a cylinder here which is floating in liquid here. So motion of solid cylinder floating in a liquid. Actually, everybody floats in a liquid. You have learnt somewhere in class 9, a body floats in liquid when weight of body, this is solid mass mg here acting. That weight is balanced by the weight of liquid displaced, which is called buoyant force. Actually, buoyancy is when we dip any solid body fully or partially liquid, then body displays liquid, and that weight of liquid displays act vertically upward, called buoyant force, and this is called buoyancy. Now, if we press this gently and release, then it may go, suppose at an instant here, it may go by distance x downward. तो ये यहाँ पर था, ये पोजीशन यहाँ पर आ गया. तो weight of this liquid x height, area A. Let this height of cylinder be capital H, and this is x displacement at an instant equal to this, ये भी x ही होगा. So here restoring force, I am writing directly, let height of this be rho and density be rho, density of liquid be rho L. So restoring force will be equal to minus AX into a volume of liquid displayed, volume into density of liquid, rho L into G. ये restoring force acting vertically up here, now carrying the body to equilibrium position. And if A is the area of cross section, as the height, so mass of solid cylinder equal to A H rho volume into density. If alpha is the acceleration, then F equal to m alpha, A H rho into alpha. Comparing these two equations, what do we get here? A H rho is the density of solid, into alpha is equal to minus A rho L G into X. So here alpha left only, A cancel and A cancel. So minus rho L into G upon H into rho into X. So this all thing constant, it become omega square. Comparing it with alpha equal to minus omega square X, we get omega square equal to rho L G upon H into rho. What is H? Height of cylinder. Rho density of cylinder. Rho L density of liquid. So omega equal to under root rho L G upon H into rho. So time period T 2 pi under root omega होता है, तो omega, so it will become H into rho upon rho L into G. You may be asked directly a question on this time period of this. So you can see many situation where you are asked to prove motion to be simple, harmonic, find time period or frequency also. So I will be telling you numericals from different competitive exam as well as other general question in coming videos. Please like the video. If you feel it is good, please like and then share and ask your friend, and you also subscribe my channel. Thank you.